let's just move on further towards the second major important topic under the coordinate geometry, which is nothing but the section formula. So what is a section formula? Let us suppose if I'm taking a situation that there is a telephone company and they just wanted to place a relay tower in between the point A and B. So let us suppose they just wanted to place a relay tower in between these two points A and B, let us suppose at the particular point P, in such a way that the distance of the point P from B is twice that from the point A. Means if we are talking about the distance, then we can say the PB distance is nothing but actually twice than P of A. So if we just wanted to find the position of such a tower, then definitely we have to look out for the coordinates of the point P. So in order to find the coordinates for the point P, under such conditions we will use the section formula. So for the section formula, let us suppose if I'll draw perpendicular over here, let us suppose if I'm drawing a perpendicular over here, so under such a condition we will derive the section formula, that how we can find the coordinates for such a particular point P who's actually dividing a line segment in a particular ratio. So let's just talk about it. Let's just derive the section formula. Let us suppose I'm talking about in general condition, and we have in general the XY plane and the 2 points. So let us suppose we have X and Y axes and we have 2 points A and B whose coordinates are X1 and Y1. Let us suppose if I'm joining these 2 points and I'm taking any particular point P, just like the case of the relay tower. So let us suppose if I'm taking this particular point P and I just want to find out the coordinates of the point P, that is X comma Y, with the condition which was given to us that the point P was actually dividing this AB in a particular ratio. That is, let us suppose I'm calling that ratio to be M1 and M2. So in order to find the coordinates of P, we have to draw some, we have to do some construction. So let us suppose I'm taking the ratio as M1 and M2, and further I'm doing the construction as I'm taking perpendicular from the point A on the x-axis as nothing but AR. Further I'm taking a perpendicular from the point P towards the x-axis again, or on the x-axis again, that is PS is perpendicular to the x-axis. Further I'm taking a perpendicular from B towards T, and further I'm taking 2 perpendicular from the point A on PS, and further from the point A again on BT from the point P, sorry, not from the point A, again from the point P on BT, which is nothing but PC, as you can see over here. So now we just wanted to find out X and Y. So how we can find it? First of all, let us suppose if I'm talking about the 2 triangles PAQ and PBC. As you can see, we have 2 triangles over here. So let us suppose if I'm starting with the 2 triangles, so I can say in the triangle, or if I'm talking about the triangle PAQ and BPC. So what can we say about these 2 triangles? That these 2 triangles are actually similar to each other by the angle criteria, because it is forming a 90-degree angle over here, it is forming a 90-degree angle over here. If this angle is nothing but theta, let us suppose if I'm calling this angle as theta, let us suppose this angle is nothing but theta, then definitely this angle is also theta, because this and this, they are nothing but parallel to the x-axis, and they all are parallel to each other. Both of these lines are parallel to each other. So if this angle would be theta, then this angle would be theta again. So this angle would be theta again. So by the angle criteria, so we can say by the angle criteria, the triangle PAQ is actually similar to the triangle BPC, and if the 2 triangles are similar to each other, then their corresponding ratio, or the sides of their corresponding ratios, are also equal. It means that PA by BP is equal to AQ by PC, which is equal to PQ by BC. We can write it in this particular formation. This is PQ by BC. If the two triangles are similar to each other by the angle criteria, then we can say that their corresponding ratios are equal to each other. Now let's just find these ratios. First of all, as we know that M1 is actually PA. So in place of PA, we can write M1. In place of BP, we can write M2. Let's just find out AQ, PC, PQ, BC. So let us suppose if I'm calling this equation as equation number 1. So as we can see, the distance from this particular or region till R is nothing but x1. This is x1, and furthermore this distance from S till S, from O till S is nothing but x. As you can see, we have this as nothing but x because the coordinates of the point P is x comma y. So its distance from the y-axis is x. Its distance, the point A's distance from the y-axis is nothing but x1. So if this is x1, this is x, then what about this distance? Then what about this distance? So the distance, this is actually nothing but x minus x1. This is x minus x1. So if this is x minus x1, then this is also x minus x1. This is also x minus x1. Furthermore, if we are talking about the further distance t, let us suppose if we are talking about the further distance t, so as we can see, this distance is nothing but x2. This distance is total x2. So if distance is x2, this distance is x. So what is ST? What is ST? ST distance is x2 minus of x. It is x2 minus of x. As you can see, we have this whole distance as x2, we have this whole distance as x. So this distance would be x2 minus of x. So if this distance is x2 minus of x, then this distance is also x2 minus of x. So let us suppose I'm calling this as nothing but x2 minus of x. This is x2 minus of x distance. Now let's just further talk about the distances B, T and QS. So let's just talk about QS first. As you can see, we have QS as nothing but, this QS is nothing but y1. This is nothing but y1. So if this is y1, if this is, let us suppose I'm calling it as y1, if this total distance is nothing but y1 and the whole distance PS is y, the whole distance PS is y. So what about PQ? What about PQ? The PQ distance would be y minus y1. The PQ distance would be y minus of y1. So let us suppose I'm writing it over here that the PQ distance, let us suppose I'm writing it over here that PQ distance would be is equal to y minus of y1. Now let's just talk about further. Let's just talk about the BC distance. As we can see over here, this distance is nothing but total of y2. This distance is total of y2, and further this distance is total of y2, and further the coordinates of the C should be of the form as its distance from the x-axis is nothing but y. Its distance is nothing but y. As you can see, we have the coordinates of P as x comma y. So definitely C's y coordinate should be y. So this is y distance. This is y distance from the x-axis, and this is y2 distance. So hence BC is nothing but y2 minus of y. This is nothing but y2 minus of y. So let us suppose I'm writing it as y2 minus of y. Now we know all the values of AQ, PC, PQ, BC. So let's just plug in all the values in this particular ratio. So let us suppose I'm plugging in all the values in this ratio, as we have the values as PA by BP. So PA is actually M1. So this is M1 by M2, which is equal to AQ. What is AQ? AQ is x minus x1. This is x minus of x1 divided by further PC. What is PC? PC is nothing but x2 minus of x, which is equal to, further we have the third, that is PQ, and we know the PQ is nothing but y minus y1, divided by, further we have BC. BC is actually y2 minus y1. This is y2 minus of y1. So we have these ratios as m1, m2, x minus x1 by x2 minus x, which is equal to y minus y1, y2 minus of y1. So let's just sort it out. Let's just sort it out as we have all the values over here. So we can sort it out as, let us suppose I am taking the first ratio equivalent to the second one, and then the first equivalent to the third. Let us suppose if I'm taking these two equal to each other, and then after I'll take these two equal to each other. So let us suppose if I'm starting with the very first ratio, we have m1 by m2 is equal to x minus x1 divided by x2 minus of x. Let's just sort it out for the value of x. Let's just sort it out. So let us suppose if I'm multiplying the terms all together, so I'm getting the value as nothing but m1 x2 minus of x, which is equal to m2 x minus of x1. So I'm getting the values in this particular form. So let us suppose I'm multiplying it as m1 x2 minus of m1 x, which is equal to m2 x minus m2 x1. Let's just take x towards one side and all the other values towards the other. So this would be of the form, let's just take m on one side. So it can be written as, let us suppose we have m2x plus of m1x. I'm taking x on one side and I'm taking the other values on the other side. So it is nothing but m1x2. So we have m1x2 and further we have minus of m2x1. So I'm taking this value towards this side. So this is m1x2 plus of m2x1. So let us suppose I can take x common over here. So this is m1 plus m2, which is equal to m1x2 plus m2x1. So hence at the end I'm getting the value of x as m1x2 plus m2x1 divided by m1 plus of m2. So this is the value of x. This is the value of x that I am getting for the p coordinate. As p was x comma y, so I have taken the value of x as m1 x2 plus m2 x1 divided by m1 plus m2. Let's just talk about the value of y. So we are taking the second ratio, m1 by m2 is equal to y minus y1 by y2 minus of y1 by y2 minus of y2 minus of y1. So it is actually not y2 minus of y1. As you can see over here, this whole distance was y2, this whole distance was y. So this distance was y2 minus of y, not y2 minus of y1. As you can see over here, we have written it in a wrong way. As we know, this whole distance is y2, this whole distance is y. So this was actually y2 minus of y, not y2 minus of y1. So let's just correct it over here as well. So this is y2 minus of y, not y2 minus y1. So let's just multiply these two terms all together. So we will get the value as m1 y2 minus of y, which is equal to m2 y minus y1. So let's just multiply the terms. m1 y2 minus m1 y, which is equal to m2 y minus m2 y1. Let's just take the m terms on one side and the others on other side. So m2 y plus m1 y is equal to m1 y2 plus m2 y1. So it means we can take y common out of it. So this would be m1 plus of m2, which is equal to m2 y1 plus of m1 y2. Let us suppose I am taking this m1 m2 onto the other side. So m2 y1 plus of m1 y2 divided by m1 plus of m2 is the value of y, means the value of the ordinate that I am getting. So the abscissa is m1 x2 plus m2 x1 by m1 plus m2, and the ordinate is m2 y1 plus of m1 y2 divided by m1 plus of m2. So these are the values of x and y. So it means at the end we are getting the value of x and y as m1 x2 plus m2 x1 divided by m1 plus m2, m1 y2 plus m2 y1 divided by m1 plus of m2. So this is nothing but called as the section formula. This is nothing but called as the section formula, in which we are finding the coordinates of the point P in this particular formation, that x is m1 x2 plus m2 x1 by m1 plus m2 and y is m1 y2 plus m2 y1 divided by m1 plus of m2. So always remember, whenever a particular point P, particular point P is dividing a particular line segment in a ratio internally. So I'm using a very important point over here, that I'm talking about the intersection, that a point P is actually on the AB internally. Internally means lying within. Internally, here I'm talking about the point P which is lying internally inside the AB line segment and dividing it into the ratio M1 and M2, then the coordinates for the particular point P should be of the form x is equal to M1x2 plus M2x1 divided by M1 plus M2 and M1y2 plus M2y1 divided by M1 plus of M2. So this is nothing but called as the section formula. This is nothing but called as the section formula whenever the point P is intersecting AB line segment in a particular ratio internally.